Okay guys, let us continue. Okay, so in general, first principle of derivatives is said to be dy dx equals to when limit delta x approaching 0 for delta y delta x. Okay, first you need to differentiate d and delta. Delta talks about the small changes, just like the example before, from 3.1 to 3.01 to 3.001. So the changes in x is very small. But when we talk about dy dx, we talk about the whole journey from q to p. Okay, so from here we have our point p, which is x and y, and for our point q, x plus delta x. Of course, because from x to this point, we have our changes in x, small changes in x. So y, of course, we have from y, small changes for y, so we have y plus delta y. So example, find the first principle of derivative of the function y equals to x squared. So we have here y equals to x squared. So you need to remember, when we talk about limit approaching 0, so there is journey from q to p. The journey from q1, q2, q3, and until it approaches point p. So when we talk about the movement of q, of course, y, from y coordinate, we need to plus with the changes in y. So y, from here, we need to plus the changes in y. So do x. Okay, x1 must be added with delta x, and then squared. So next, what are we going to do? We need to expand this function. So x plus delta x times x plus delta x. Okay, so we have x squared plus 2x delta x plus delta x squared. So remember, our y is equals to x squared. So substitute the value of y. So x squared plus delta y is equals to x squared plus 2x of delta x plus delta x, the whole thing squared. So x squared can be cancelled out because it can be subtract. So delta y is equals to 2x delta x plus delta x, the whole thing squared. So as we can see at the right hand side, we have the common term, which is delta x. So if we have common terms, so what we are going to do, we just factor out the common terms. Okay, next, refer back to the formula for first principle. We need to have delta y, delta x. This only delta y. So delta y, delta x should be equals to x plus delta x. But when we talk about derivative, okay, before, derivative is also said as differentiation. Okay, so dy dx is equals to limit delta x approaching 0 for delta y, delta x, in which dy dx is equals to limit delta x approaching 0 for 2x plus delta x. And then, previous class, for Cikgu Nelson's class, Cikgu Nelson have taught you on limit, right? So what are we going to do when we have delta x approaching 0 for this function? We just substitute the value of 0 in delta x. So we have dy dx is equals to 2x plus 0, and we have our dy dx is equals to 2x. Again, dy dx is to find what? Is to find the gradient tangent at point P. Okay, so dy dx is said to be gradient function. But what if I will ask, what is the gradient tangent at point P? So point P, let's say our point P here is 39 tadi. So what is the gradient? So when we talk about gradient, we need to have the value of x. So our point P is 3. So just substitute 2 times 3. So 6. So 6 is the gradient tangent at point P. Okay?